Here's your study guide for Pythagorean theorem practice and scientific notation. To begin, you're going to label the triangle below using the following vocabulary. Remember, the hypotenuse is directly across from the right angle. So the hypotenuse is the longest side of the triangle. The sides that make up the right angle are called the legs. Furthermore, we could use letters A, B, and C. The legs are your A and your B, and your hypotenuse is your C. For letter B, you're going to write the equation for Pythagorean theorem. Remember, on the state test, you will not be given this formula. It's A squared plus B squared equals C squared. For the next set of questions, we're going to use Pythagorean theorem to solve for the missing side length. Okay, for number 1, it's always good to write the formula. A squared plus B squared equals C squared. And next, let's look at our picture and see what we're looking for. Across from the right angle is always the C. So for the first one, we are looking for the C. That means we have the legs. So 15 squared plus 9 squared equals C squared. 15 squared, that means 15 times 15. That's 225. Plus 9 squared, 9 times 9 is 81. Gives us C squared. Now go ahead and add that together, and that adds up to 306 for C squared. Don't forget, you have to do the last step, which means take the square root to get C by itself. And the square root of 306 is approximately 17.5 for C. Then go up to your picture and place 17.5 in the picture to make sure that your answer is reasonable, which it looks like it is. For number 2, we're going to begin the same way. Write the formula, A squared plus B squared equals C squared. Now look at your picture to find out what we're looking for. Across from the right angle is the C. So where the letter C is, we're going to put in 24. We're looking for one of the legs. So A squared plus 20 squared is 24 squared. 20 squared is 20 times 20, which is 400. And 24 squared is 576. To isolate the variable, or to get the A squared by itself, we're going to subtract 400 from both sides. That leaves us with A squared and 176. 176 would be way too big for a leg. Remember that last step. Take the square root. So A is approximately 13.3. Put your 13.3 into your picture and just make sure that it makes sense. Our legs should be smaller than the longest side. And our last one, it looks like a rectangle that is crossed, cut in half with a diagonal. So if I just focus on the one right angle, I should be able to find this leg. Looks like we have a missing leg here. Okay, so across from the right angle is the C. So 17 is our C. So we're looking for a leg. 10 is our other leg. 10 times 10 is 100. 17 squared is 289. Okay, now we need to get a squared by itself. So using our inverse operations, we would subtract 100 from both sides to get a squared by itself. And 289 minus 100 is 189. And of course, by now we should know the last step to get a by itself is to take the square root of 189, which is approximately 13.7. Put that in my picture. Make sure that it makes sense. Our longest side is 17. Now we're going to apply Pythagorean's theorem to a word problem. So it says Martha walks south and east. So 4 miles south and 7 miles east. How far is she from her starting point? Now, you guys should know, your prior knowledge should tell you with directions, north is up, south is down, and then eat. So never eat soggy waffles is a little phrase. All right, so we're going to go south. So 4 miles south. And then Martha walks 7 miles east. Okay. Now it says, how far is she from her starting point? Well, here's her starting point. Okay, so how far is she from her starting point? So we're looking for the C. Because these two, this direction going south and east makes a 90-degree angle. So we're looking for the C. Okay, so write our formula. A squared plus B squared is C squared. And we're going to fill in, of course, across from the right angle is the C. So we know that we have our legs. So we have 4 squared plus 7 squared is C squared. 4 times 4 is 16. 7 times 7 is 49. I'm going to go ahead and add that together. And that gives me 65 is C squared. And that final step, take the square root to get that C by itself. Then the square root of 65 is approximately, in fact, I should be doing like little wavy equal signs. It's approximately 8.1. So she is about 8.1 miles from her starting point. And again, here, the set of directions helps set up that problem. Okay, number 5 is another application problem. Lyle recently purchased a 15-foot ladder to paint a second floor window, which is 15 feet off the ground. For safety, the ladder must be placed at least 6 feet from the wall. Is the ladder that he bought, is it long enough? So let's take a look here. It's a 15-foot ladder. The window, okay, so here is the second floor window. So the second floor window, I'll just put here, and here's our first floor. Okay, so this is 12 feet. And he must place, for safety reasons, he must place the ladder 6 feet from the wall. So we want to see, is a 15-foot ladder going to be long enough? There's my ladder, and my ladder is 15 feet. Okay, so let's see. Here's our right angle right in here. So our C is 15. So let's take a look. A squared plus B squared equals C squared. All right, so we have our legs. So 12 squared plus 6 squared. And we want to see what that ladder height would be, and if 15 feet is long enough. So let me keep going without the 15 and see what happens here. 144 plus 36 to get that c squared. Let's see what we get here. 144 plus 36, that is going to be 180 for c squared. And then that final step, if I take the square root of 180 is 13.4 for c. So what that is saying is we need at least a ladder that's 13.4 feet. And we have a ladder that's 15 foot. So is the ladder long enough to reach that window, or would it fall short? So I would say yes, the ladder is long enough because we need it to be at least 13.4 feet. Okay, so some little description there needed that, kind of shows that that this ladder would be long enough to reach that window. Okay, next we have some more application problems, and these start to get a little more complicated, so take your time. Okay, a baseball diamond, which is square, has sides that are 90 foot long. How far is it from home plate at one corner to second base at the opposite corner? Round your answer to the nearest whole number. Okay, so I'm going to grab a square because I can on this little program that I have. You can go ahead and draw a square. Okay, so home plate would be down here, and then first base, second base, third base. And it said that, from home to first base is 90 feet, from first to second is 90 feet, second to third is 90 feet, and third to home is 90 feet. The question asks, if you're like a catcher or something, how far is it from home plate to second base? So here's our right angle kind of over to the side here. So that would mean we're looking for the hypotenuse. So following our formula, a squared plus b squared equals c squared, we're looking for the c. So across from the right angle is the c. That's what we're looking for. So our side lengths are 90. 90 squared plus 90 squared is c squared. Okay, so that 90 squared is 8,100. Okay, so I'm going to add that together. Okay, and then the final step is to take the square root to see how long that hypotenuse is. And it says to round to the nearest whole number. So it's approximately 127 feet for the catcher to throw from home base to second base. Home plate to second base. Number 7, what is the length of the diagonal D of the rectangular prism below? Round your answer to the nearest tenth. Okay, this one is going to take 2 steps. The first thing we need to know is that, or need to see or identify, is that we need to find the diagonal of the base. Okay, so that yellow line that I just drew, we need to get that diagonal first. So that is in itself a right triangle down here at the bottom of the base. So let's get that first. So a squared plus b squared equals c squared. And the 2 legs there are 8 and 2. So 8 squared plus 2 squared is c squared. Okay, so I know this is 64 plus 4 is c squared, and that is 68 for c squared. And if I just stick with our pattern and take the square root, that gives me, I get kind of a decimal here. I'm going to round that to 8.3 for c. Okay, so that means that this length right in here is 8.3. Now I can see on this rectangular prism that this is a height of 5. So now I'm ready to do that secondary right triangle, which is now here. I'm going to outline it in green. So now we're going to do this triangle. Okay, so there's a secondary triangle. So now I can get that other slant height, or that other diagonal, they're calling it. Okay, so now I just found out that that now was the hypotenuse, now is a leg, is 8.3 squared plus 5 squared is c squared. So it's like a right triangle at the bottom of the base, and now we have a right triangle within the rectangular prism. Okay, so let's see. I know this is 25, 8.3 squared. Okay, so now I'm going to add that together. Okay, so that is 93.89 for c squared. And my final step is to take the square root of that. And then that gives me about 9.6, 9.7 if I round it. Okay, so that diagonal is 9.7. Okay. So that was tricky because there's two right triangles embedded in there and you have to kind of pull them out. Okay, here comes kind of a complicated one. A cone has a slant height of 13. Okay, that's this measurement right here. And the diameter is 10, so that's going all the way across the base of the circle. What is the volume of the cone? Round to the nearest tenth, and we are given the volume formula. So thinking back when we use these formulas, this height that we need 1/3 times pi times the radius cubed and the height. We need the height that goes right to the base of the cone. So I'm going to do the line in purple. We need that height for the problem. In this one, we have the slant height. Do you see this right triangle right in here? Do you see it? And there's the right angle there. So we can treat those as legs because the right angle is in the corner there. So we don't know. So I'm going to just pull that out. Let's pull out this shape. Okay. So we do know the diameter going all the way across is 10. So half of that, the radius would be 5. We know the slant height is 13, and we don't know this other leg or this height of the cone. So that is a leg. So going across, this 13 is the c in our Pythagorean theorem. So we have to do that first. A squared plus b squared equals c squared. Okay, so we do have one of the legs, 5 squared. We don't know the other leg, but we do know the slant height, which in that right triangle is the c. Now we're going to go ahead and solve this like we know how to do. 25 plus b squared, and then 13 squared is 169. Now use your inverse operations. Subtract 25 from both sides. B squared is 144. And then our final step is to take the square root. So B is 12. So right here, this is 12. Okay, and that makes sense. So now going back to my picture, the height of the cone from the center of the base to the tip of the cone is 12. So let me kind of redraw this cone over here. So for the formula, we need the radius, which is 5, and the height, which we just found out is 12. So now I can use those numbers in my formula, which is given to you. So 1/3 times pi. It doesn't tell me to use pi key or the pi button. So I'm going to use the pi key that's in the calculator. And then the radius squared, so it's 5 squared. And then we found the height, which is 12. So now we're just going to type all of that in. And that is 314.159 dot 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 dot. And then it says round to the nearest 10th place. So just as a reminder there, that's one position past the decimal. So I look behind it. If the number behind it is 5 or greater, that rounds up. So we get 314.2 centimeters cubed for our volume. Whew. Okay, so that was a lot. So we had to pull out that right triangle and use Pythagorean theorem to get the height of the cone, not the slant height, and then use the height that we found in our formula and find the volume. The square pyramid shown below has a slant height of 8 and a base with sides of 10 units. What is the length of the height? Round to the nearest 10th. All right, do you see that right triangle in there? So what I'm noticing first is this whole side length of this square is 10. So this would be the halfway point. It would be half of that. So that height right there is 5. So now if I use Pythagorean's theorem, and I just focus on the inside right triangle in there. We don't know what that leg is, but we do know that the other leg is 5 squared. And that slant height is now the hypotenuse. See, that's across from the right angle. Okay, so we're going to go ahead and solve this. A squared plus 25 is 64. How do we get a squared by itself? We subtract 25 on both sides of the equal sign. So a squared is 39. And that final step is to take the square root. And the square root of 39 is approximately 6.2. So the height of this pyramid is 6.2. Okay, moving on to scientific notation, it will be perfectly acceptable to put your calculator in science mode. Remember, we hit the second button and the DRG button and arrow over to science. We can also try to use some of our shortcuts if we wanted to. I'm noticing on the first one that it's an addition problem, and if we're adding in scientific notation, we would have to have common powers, and we don't. So I would just use my calculator in science mode. Be sure to include the parentheses around each quantity. And when we add up that first one, we get... So I'm not going to adjust it or anything. I'm just going to type it in the calculator as is, making sure I use the parentheses. So if you typed that in correctly, you would get 6.25 times 10 to the 6th. The second one as well, an addition problem with scientific notation. Our exponents would have to be the same on our powers of 10, and they're not, and I'm not going to adjust it or anything. So again, make sure you use your parentheses on your calculator and that you're in science mode when you add these up. You should get this answer right here. And for the third one, once again, it's not ready to roll. We don't have the same powers of 10. Just another reminder, I always include the parentheses when I'm typing these in. Carefully type them in. You'll notice on this one you do get a negative for our coefficient. That happens sometimes when we have a bigger number, a smaller number minus a bigger number. Okay, and I'm going to continue to use my calculator and type these in. This is a subtraction problem. Make sure you include your parentheses. For this one, this is another negative because it's a smaller quantity versus minus a bigger quantity. And make sure you're typing these in and practicing and getting the same answers. Okay, for number 5, there is no symbol right here between them, and it's just parenthesis butted up against another parenthesis. So this is a multiplication problem. So we could do our exponent rules where we multiply our coefficients and then keep the base and add the exponents. You could do that. Or just continue with your scientific notation button and type it in as you see it. And I came up with this answer here. Same thing for number 6. It's a multiplication problem because there's no symbol in there. And we could multiply the coefficients and keep the base and add the exponents, or just use your scientific notation button. Okay. And then the last two, 7 and 8, these are division problems. So we could just do regular division with our coefficients and then keep the base and subtract the exponents. Or once again, use your scientific notation option on your calculator. Just make sure you put the quantities in parentheses. So put your first set in divided by your second set. And this is what I got. And finally, the last one, again, another reminder, use your parentheses. 6.2 times 10 to the third divided by the second quantity. And I got 1.59 times 10 to the negative first. Okay, so just a reminder there, just to use your calculator, be very careful, include the parentheses. Number 9, the volume of the Atlantic Ocean is about 3.1 times 10 to the 17th cubic meters. The Mississippi River has an annual flow of 6.3 times 10 to the 11th cubic meters. How many times would the annual flow of the Mississippi River fit in the Atlantic Ocean? Write your answer in scientific notation and round 2 decimal places. Okay, so here's the key. How many times? So how many times would the flow of the Mississippi fit in the Atlantic Ocean? What's that saying? What that is saying is, what would we times the Mississippi River by? Okay, what would we times this by? Times what to get the Atlantic Ocean? Remember, the ocean's going to be bigger than the river. So we don't know how many times that would fit into the Atlantic Ocean. So we can use that idea of inverse operations. The inverse of multiplication is division. So we can take the Atlantic Ocean, which is 3.1 times 10 to the 17th, and divide it by the Mississippi River flow. Okay, so now we could do what we learned previously. We could divide the coefficients and subtract the exponents. Okay, or you can use your scientific notation button on your calculator and divide those two quantities. Carefully type that in, and you should get 4.92 times 10 to the 5th power. So this means it would take 4.92 times 10 to the fifth power. It would multiply that by the Mississippi River to equal the Atlantic Ocean. Okay, so that was a tricky one. How many times greater or how many times would one fit in the other is actually a division problem. For number 10, a color photograph taken with a digital camera is converted into a digital format using 4 times 10 to the 0 power bytes per pixel. Photographs taken with the camera each have 2 times 10 to the 6 pixels. How many bytes are there in one photo? So how many bytes would be in one photo? Okay, so we would take our digital format, so our 1 byte, and we would multiply that by photographs taken with each camera. Okay, so you're going to go ahead and carefully multiply those. And again, use your scientific notation button if you're comfortable with that. And we get 8.8 times 10 to the 6th power. We could have also done our shortcut where we multiply the coefficients and add the exponents, and you can see that would be the same answer. Okay, so word problems, you just have to be a careful reader and try to decide, am I adding, subtracting, multiplying, or dividing these problems?